2023. So when I got the invite, I pulled out slides from last year, and I was like, what's changing last year? If Oxford, you realise some of the challenges we've had in delivery of the project, and that not an awful lot has changed on site that can be seen, at least. I'll talk you through some of the challenges we faced, the wider strategic case for what we're doing, and some of the unique features of Oxford that by the time we're finished will leave a bit of a legacy that we can be proud of, even though we're going through a lot of challenges at the moment after all that's forgotten. So just a bit about myself then. Joined the Netrail graduate training scheme back in 2009. A pleasure working on Reading Station, one of my early projects, Crossrail up and down the route. Most recently, the West Inner stations. So West Drayton through to Acton Main Line, including Ely Broadway, Hayes Parlington, Southall. Some West of England platform extensions for the Cascade and Rolling Stock West, taking the DMUs down there. And latterly Oxford, and also Stockley Flyover, and the Great Separated Junction into Heathrow. So I'm the DP for Netrail. So people don't know what the DP role is. You coordinate technically, basically technical lead for the client. Advise the client and deliver for the route asset managers a compliant set of requirements, work with the sponsor project managers to deliver the scheme, and then liaise with the supply chain, so designers and contractors, to ensure the client gets what the client wants and delivers value for money. So let's have a look at Oxford then, setting the scene. If anyone knows the rail network around here, which you can do, the sketch there isn't strictly railway. So Didcot's been omitted, for whatever reason. It just kind of shows you that you can't view the rail network in isolation. It's got to compete with other modes of transport and other means of communication as well. It has to be attractive. The journey times have to be attractive, and there has to be capacity and a comfortable journey. So in the Oxford area, there's been renewed input into the Oxford-Cambridge arc with East-West Rail, increasing that connectivity, moving the focus away from Oxford, from the London connection slightly. And as you'll know, Oxford now has a competition in terms of rail service into London, with the Chiltern line being upgraded, and the northern connection through Bicester. And that was one of the early stages, a precursor to Oxford Phase 2, which we'll just touch on in a minute. Then we've obviously got the connection to South East, the delayed electrification that Oxford is providing provision for, and some limited elements. So that's foundations where it's appropriate to do so, bosses for portal cantilevers to support the OLE, but that is it to a point, and kind of the electrical systems CBC sized appropriately, but not an awful lot of spend at this point, because we don't know when electrification will be given the green light again and technology moves on. Just touching on a few other points on that slide then. So journeys increased by nearly 50% more than the UK average in the Oxford area alone, and projected to increase before COVID, with a fairly steep trajectory. Oxford made good recovery post COVID. So in the 21-22 year, 30% reduction in season tickets. But leisure journeys, and particularly in the Oxford area, are very robust and growing. And there's a focus on the Oxford Football Club and their relocation to the north of Oxford, and the impact that has on the station. And then we've got future schemes that Oxford Phase 2 enables, so the AUX projects, including Canley Plus, potential 4-track is south of Oxford, and other schemes that I'm not going to touch on today. But there's a lot more down the line that we need to deliver this project to enable. We've got strategic freight network, so through Oxford, not just Oxford Station itself, but 2.5 trains per hour by 25 and 4 trains per hour by 2043, in addition to the enhanced service that East West Rail, Great Western, and Cross Country want to implement. And you can see there in the wider Oxford area, the local plans show 100,000 new homes in Oxfordshire. Is the infrastructure. So Oxford Phase 1. So this consisted of a substantial remodelling and resignaling in the Oxford area. So access counters throughout, Siemens infrastructure data lock, interlockings down in Didcot, crossovers to the south and the north of the station, enabling the bay lines to be introduced. Service by Chiltern Railways today, but providing future access for East West Rail. So that'll be the principal routes that they'll kick off with, and then when we complete the new platform 4, the new platform 5, that gives them additional operational capabilities. So then we have this is where I picked up the projects in 2020, late 2020. We completed again the new top building, the new platform 1 and 2, but the western side of the station was undeveloped at that point. You can see the old youth hostel, where I was now purchased land, demolished the youth hostel, and that's now a temporary bus turning circle for the time in which we've closed Botley Road to complete the works. Go into that into some more detail in a minute. We've got a bit of scene setting, so the existing Oxford Station concourse, known by some as a bit of a cattle shed in terms of its sort of basic construction. So there are future plans as to part of the Oxford Master Plan. So this is an enabler to that, to develop the main entrance, bring that up to date, including a new platform 1 line that runs all the way through across the new bridge that we're going to enable as part of this scheme. New master planning in that area, new bus turning and new bus terminal facilities on that side of the station. So then delving into phase 2 itself, it's 50%, I'd say, a rail infrastructure project. We have delivered a lot of that already. Summer 23, we had a major blockade, 4-day blockade, in which we delivered a number of phases of the work. So most of the resignaling throughout. So we've upgraded to 90 mile an hour through running on the main lines, 75 mile an hour bi-directional, and then 60 and 90 on the reliefs. In part, obviously, through the station, it just slowed down slightly to 60 miles an hour and 75 through the main platforms. We're basically full bi-directional running everywhere. That was one of the key outputs for the scheme. Some deferment to the north on the OXD towards Bicester, not the OXD towards Bicester, on the DCL itself. Whereby there are level crossings that we haven't yet closed, and that's postponing the line speed and the headway improvements in that area. That's a benefit that's still to come once we get those over the line. If I get time, I'll go into those, but I'm really focusing on the Oxford phase 2D and phase 2C stationary works. That's what I'm the DP for as well for those early on, but not lastly. Now phase 2E is the full signalling scheme upgrade. So I haven't touched on this phase 2B. So that was the other main deliverable that we achieved back in 23. So that's full upgrade of Oxford North Junction, which went from 25 mile an hour to 75 miles an hour, which enables trains to accelerate much faster out of Oxford Station to the north, and allows freight to clear through faster if it's going up the OXD, and generally a large improvement in terms of the output to the north of Oxford. So that's 3 G switches delivered as a modular plus arrangement. So if you're not aware of what that is, modular bearers enable tilting wagons to be used. There have been some instances of premature failure of the clamps on the bearers themselves. I don't know the full reasons for that, but potential reasons might be uneven settlement or installation practices. Because there have been a lot of sites where they have worked well and haven't caused any issues. To mitigate against that, we still needed because this site there was no build-up areas around that site, obviously large G switches, so I had to build them in the hole in the time we had. We went to this modular plus arrangement, so that's 3 long bearers around the crossovers, and then 1 in 3 other key points throughout the switches, so long bearers that tie the unit together and gives you that resilience to potential differential settlement across those. It's also a good site because we weren't leaving anything unopened to traffic and getting your differential consolidation across different roads. So they're operational. They've been working well, and improving journey times to the north of Oxford. Resignaling has also worked well, and we've implemented a lot of the enablers for the new platform 5 line phase 2D. So we've installed a new turnout to the south, and in the data we've got a new turnout to the north. We don't yet have the S&C in because it's very, very close to an access road that we don't yet have full access, still owned by Walton University. So that is works program for next year, in the blockade next year. So that's an overview of the overall scheme, the phase 2 scheme that we're delivering. So we're going to drill into the detail around the station area, Botley Road Bridge, Sheepwash Bridge in a minute. But I do invite, and I want this to be potentially quite interactive if you'd like. So open the kind of room to questions at this point, and throughout the presentation really, and invite heckling, or if I mess up, do have a laugh. So talked about some of the benefits. We've got the level crossing closures, so that enables the 2 freight paths. That again is unfortunately deferred until we get the revised bridge designs, which have been developed with Oxford University and a developer who have got a large housing development in that part of the world. One of them, the other one is so there's 3. There's one that's just used the word crossing, so that's an easy one to close. And then we've got the 3rd one, which has been replaced when they're a standard footbridge. So there's only one that's a little bit more involved in terms of the discussions with the developer and with Oxford University. We've got the high-speed crossovers, so I've talked about that. And then we've got the Botley Road Bridge, enabler for the platform 5 and the future Eastern Through platform, and the station works in the western entrance. I'll let you read what's on that screen, because I'm going to talk about it a lot with the next slides anyway. So yeah, phase 2B, that was the high-speed crossovers. See there some of the photos from last, well, one of the photos from last year. Does anyone have any further questions?
It's just intrigued. It feel like that long since Oxford North was renewed before. How old was the S&C at Thames?
Was it definitely Oxford North? Was it Oxford? So there's Oxford Station North and Oxford North. That's Oxford North Junction. You've got Station North, which is what we did as part of phase 1. So this was
not a local.
This S&C was much older. So you've got I'll just go back to the slide that did show. This is Oxford North Junction, Oxford Station. It's part of those works just south of the new station sidings, EMU, future provision for EMU stabling sidings there. But I don't know, apart from maintenance replacements, that the 25 mile an hour have been in for a while.
Well, at the north end of the line, there was a double compact double slip or whatever you like to call it,
at the station.
the limiting speed to Oxford in the other direction.
Yeah.
Yeah.
I think we've taken that out.
Yeah.
Now, absolutely, as part of the Oxford, the phase 1 works, which you can see on the screen. So yeah, in the area between the bridges over the Thames to the south and basically the ring road at the north, it's all upgraded now, and obviously from Didcot to the limits to the north, fully re-signalled. So ready for electrification. That was obviously one of the drivers for the re-signalling as well.
Question on.
Yeah.
Around conflicting moves with stabling of stock. So the coach and stock moves from sidings on the up and down side.
Yeah.
That always seemed to be, as a passenger stood on the up platform at Oxford, a massive frustration when everything had to wait for a down direction service to cross over. Is that now?
It certainly will improve. It's not eliminated. You've still got the 25-mile-an-hour ladder coming over, and certainly for releasing trains in the up direction, just wait for that to spread over. What you do have, because you've got the 2 platforms now rather than 1 on that side, is you've got the ability, at least coming from London, to run another train to the platform while that junction is blocked. You've also got, if you've got less wait time for anything heading north to then take your trains over at grade.
On that diagram, next to yellow Botley Bridge,
Yeah.
there dotted line, I assume that's the old level crossing,
It's the old level crossing, yeah.
which we had to keep.
Yeah.
Because tall vehicles couldn't get on the Botley Road Bridge. But I don't think I ever knew it being used.
No.
Tonight.
I think it's also kept. So I've heard it's also kept for fire brigade access in times of flood, even. So emergency vehicle access. One of my predecessors, I won't name him, on Oxford phase 1, decided to plonk a DNO equipment cabinet right on that level crossing. So essentially became out of use in 2018. We've now officially stopped it up with, so funnily enough, that actually was officially public highway.
Yeah.
Section 278 agreement, that's now stopped up. It's now no longer a level crossing, but it's still, the kit's still there. Funny enough, with the widening, we're essentially taking out where the level crossing was. And that is now going to be a cycle box, as you're seeing. Yeah.
Sorry, one more before you get to Marley Road. Are we finally going to take that hideous vertical hump in the bridge? When you stand on the up platform, you can see the huge hump in the bridge. Is that on with the deck?
Yes. You'd hope so, wouldn't it? So it'd be fully ballasted. So see the current track is on timber.
No, concrete.
Concrete, thank you.
Like designed it.
Yeah.
To go back a bit.
Yeah. I'll go first about the counterforce behind it. I was speaking to one of the engineers involved in the project analysis in Oxford that put that bridge in. Previous northern abutment had counterforce behind it they weren't expecting, so when they piled through it, initially they were hitting those.
Don't know about that.
No. Do you know anything about them on the other side either? I guess you don't.
Well, I do know about it was I knew the envelopes there.
Yeah.
That was on the original drawings.
The inverted arch.
Under
That's it,
yeah. But also, we'll find that if they haven't done it, the brickwork extremely hard.
Yes.
Because the original 2 weekend sessions, I think, one of them overran because they couldn't break the brick out.
Yeah.
Break the bones. So, and the other thing on there, you do say about satellite over the buses. It was when we rebuilt it in 1977. We actually provided additional 3 or 4 inches on clearance to enable standard height double deck buses to pass beneath the tire. And the buses that were running up there until we closed were, I believe, standard old decks. There were no restrictions on, when the older buses ran out, obviously the park and ride and the searches and swindling and so on, ran under it. And they were standard buses. The non-standard bus they used to run had, if you recall, 4 seats upstairs and a side gangway. They also had buses. Sorry?
Like the old Reading buses.
That's right, yeah. And that's what ran before.
Yeah.
We are able to give them an extra few inches by using that type of structure.
That's all we're doing. We're only giving them, so it's what is it, signed at 4.0 meters, but obviously with the vertical curves, you've got slightly more than that if you're running a bus under there. I was always told that Oxford had to order slightly reduced height buses.
I don't think so, I understand.
But one of the key outputs for this is to increase the usable headroom to 4.5 meters.
Well, on that, as it was there, without lowering the road, which was, never had money to do what we'd like to do. You actually also ballasted deck on the bridge, conventional ballasted deck, with as finished construction depth we could get. We'd be raising the track a metre, which would give you the problem stems to the platform.
We are moving to a composite deck, so steel simply supported, main deck under the track, ballasted, reduced ballast depth, around between 200 and 250. There.
That would have been, with the one, what would have put in there would be a box girder probably. But that was the structure there for box girder from rail level softened 900 millimeters. The standard ballast depth.
So to run through, obviously, some of the benefits we touched on the buses. Oxford have large orders that they're realising now of zero and low emission buses that require more construction height for batteries. You can also see the other benefit is at the moment, just showing off carrying a small brick arch 2 meters wide that all of Oxford are currently walking and pushing their bikes through as we close the road. We're moving to 2 4-meter wide boxes with segregated cycle routes, providing much better access with good vertical gradients as well. Slightly lower than the current pedestrian access today, but not by much. And then a nice level threshold into the station. As with a lot of new build stations these days, security category A, so consider blast and HVM, hostile vehicle mitigation, around the station. Obviously trying to do that in a sympathetic way because it is an urban environment, but it is also a residential environment. You've got lots of student residents and private residents alongside the station. So achieving that through the use of planters and cycle parking and other elements that are designed to be used not just with concrete blocks, but designed to be sat on and create a nicer around that area. See, one of the photos, one of the first things we did when we really got going on site, we had to close the road. We decided with the sheer number of utilities divergence, the only way we could get that in was by full road closure, not partial road closure. And I'll go into detail a bit on why for this.
And
Hostile vehicle mitigation. Similar, I think, but yeah, and they're all designed based on if you look at the where a vehicle can drive, the speeds it can get up to in a hostile manner, and then what sort of defences you need to put up to keep it outside and away from the vulnerable space within it. So you can see there on the photo in the top right hand corner, you've got the signal gantry that went in as part of the phase 1 resignaling. And then the bottom right hand corner, sorry, another issue that probably where Oxford faces from time to time. That's flash flooding, but we very rarely, fortunately, get flooding in the Thames as well. And with climate change uplifts at the moment, we are designing the western entrance to be flood proof. It will tolerate a flood level of 1.5 meters. So all of the cabling and everything is worked out to rapid recovery following a flood event. So it will be closed during a flood event. Like road will close, won't, you know, you're only about to get around this part of Oxford in a boat. However, the station is designed to remain operational given the level of the actual tracks, and the city side will remain open. We could have enabled, you know, brought it all up out the flood level. However, day-to-day usage of that station wouldn't be favourable. We had to put an additional lift in to get down to the subway, which serves the new platform 4-5 from the western entrance, and steps. And we just obviously decided in the project that was the most favourable option. Obviously, not designing in sort of crazy levels of resilience for the flooding. And obviously, we've got to design the lift to be able to recover quickly from that flood scenario as well. Again, a bit more detail then on Botley Road Bridge itself and the construction challenges. The first walkouts I had in the project was at Thames Water. We just engaged with them under the C123 for utilities process. So we're getting a cost together and a agreement together for diversion services. And on one of the drawings, it showed kind of a sheet pile line at the southern extent of our works, and then an assumed position of the Thames Water main and sewer. Now these are strategic assets for Thames Water. So the main serves Oxford city centre, and there's no other means to bring water in. So it needs to remain operational at all times, and they get a bit twitchy when you start piling right next to it. So we very quickly realised that actually we had this rail systems job that's pretty much implemented now platform, the new platform 5 at Oxford. But the last few years have been a utilities job, really, in terms of diverting in a fashion that enables the construction of our new bridge and future access to the to those assets. So to date, we have now diverted the Thames Water main. We're just working on the connection details at either side, but most of the piping is in. The only asset that's not under the highway due to the falls is the sewer. Obviously, we didn't want to pump a 1.5 metre diameter sewer, so that falls at the natural grade just south of the bridge. Actually, that side of the road. So we're sinking 2 5 metre, so 5 metre thrust shaft and a slimmer reception shaft for the micro tunnelling system. That'll be 900 mil diameter, active diameter. The actual casings are a bit larger with a dry flow channel at the base of that, and that will be connected in. We've also had to divert HV cables up to 33 kV. Oxford University have a telecoms network that serves all of their residents in the area. We've diverted that. BT, an awful lot of BT infrastructure, including that was our second biggest spend actually after Thames Water, Virgin Gas, and some others I haven't yet mentioned. Global Crossing actually is another one, Lumen fibre, so obviously heavily use our network and have a key breakout in the Oxford area. So in terms of the build up then of the bridge itself, so as I mentioned, going to ballasted with small transitions on either small stiffness transitions, just accommodating for the change in ballast depth and subsoil stiffness. Box abutments, so they carry the weight of all of the decks and also provide the access through for cyclists and pedestrians. Next section I'll show you the long section through the bridge along the highway, and it shows you how the loads are taken into the piles. They're fairly hefty piles, bigger personally I think they need to be, but I'm trusting the designers on them, sort of 30 odd meters deep into the Oxford clay. So the first bit isn't that usable; it's very saturated gravels, and then beyond that is very good clay. What else can I talk to you about there? Drainage for the actual deck is the highway itself. So the two side spans fall into the centre. Back of rail deck drainage is also drained out. Got split in asset owners. So Oxford County Council own the highway, maintain up to the waterproofing system, and maintain the drainage within that. And then it falls out through. There are structures assets and drainage assets, and then into pumping station, attenuation tank, and then with a flow control device, and then out to the Thames water sewer, where we're using our existing outfall agreement.
Simple question. Where's where was the old road? I thought was it
Just about see that. Sorry, I should have hinted at that. So you've got in green there. You've got the old rail span. So there's the railing there and the deck there. Got the old road level. Sorry for those online. Maybe you can see my finger. is around here. So we're dropping the level about a metre
yes,
of the highway. So that lets us more construction depth on the bridge. We played around a hell of a lot with the vertical curves. What we were going to accept, we're right down to 10% at either side, and we settled on a sweet spot of around 6.5% gradients on either side, as being the optimum that didn't involve any more land take to be able to build it, any more retention. Drop down fast enough to clear the new bridges. Because we've got the central span that we're replacing today, but we've got the two new side spans. I haven't talked too much about those. One is obviously for platform 5. The other one on the city side, we've got a GA just to show you guys. So sections through the north and the south of the structure. So we're looking towards London there. Looking towards Oxford Station to the north there, and that's the south. So looking at either side of the bridge. We've got the new western span there, serving platform 5. So that will open as a rail span, and then you've got the new eastern span that will serve the future platform 1. In the meantime, we're going to use that as a pedestrian span, replacing the existing steel 2 metre wide footbridge, standard sort of narrow girder footbridge over Botley Road. And the reason for that is, as part of the master plan, they want a landmark, potentially suspension or similarly fancy bridge over Botley Road when that bridge comes into service. And that basically avoids the abortive work of us installing a standard footbridge that's then ripped up. We might as well use the existing, the new rail line in a temporary state. So what that means is we're just move the waterproofing up slightly to protect the rail deck with a layer of protection, and then standard it's just fairly basic tarmac surfacing over the top for a number of years before that gets built, with additional protection on the inside of the span, so it's not climbable, but maintaining some sort of perforation so you can see out from the bridge and give a similar experience to today. And the alignment is quite good as well. It sits more or less in line with the current footbridge, enabling the existing ramps to not be reused, but essentially the similar gradients and similar time points to be used. So limiting the impact on the city side of our project. So looking at it from a structural point of view, we've got the 2 spans that's supported by the box section, short section to box section, abutment on either side, and then the loads taken down to the power cap. The interesting bit on this one is that in order to keep the railway operational and build the power caps, we're sinking temporary steel piled cofferdams to be able to install these power caps inside the existing railway, which is seeing green there. It's more or less in between these two power caps. You see how tight it is. And then installing box sections that then span between, so take all of that rail load into the stiff box sections and then span into the power caps, enabling the power caps to be introduced and ready to take that load. And then these box sections fabricated on site and then lifted together and stitched within a possession on the south side of the highway. At the moment, if we go back to the section, so existing is still in situ. Within the block, we play around with different lengths of box, but it's typically sort of 5 to 7 days. We take the deck out, we excavate and demolish all of this back to the piles that we've previously put in, and then we install those sections being craned in. This box section is installed prior to that blockade, with the use of the arch, or once that's in, this element to enable pedestrian and cycle motorbike pushed access through the worksite.
Question, Lawrence, about the highway. So that's going to be installed by owned and maintained by Oxford County Council.
Yes.
And is it that hideous beanie block curb system?
Yes, I think so. Thank you. Still hasn't.
Glad we're not owning it.
No, it's okay. It's what they want.
Yeah, Marshall's got to.
Yeah.
I think it's every
Still not just, we're still refining the details, but yeah, that's the way things are going. So initially to start the works, we installed through the inverted arch 5 courses of, and it was really hard brick that ran all the way to the end of the retaining walls either end, which was then lined by puddle clay for providing that waterproof layer and resistance to any uplift. So we hit and missed, cut a section out, piled, cut a section hard through there. So now we've got full continuous piling either side that enables us to go down quite a depth to install a base slab, again to prevent uplift, fair mass of concrete, piece of concrete down there, and then started to stack up the various utilities below the highway, all on the London side of the structure, to this side, such that when we slide the new or build the new box abutment within it, the utility owners still have better access through it. You still got to get through a structural slab to be able to enable any changes. So obviously they're all designed and drawstrings added, and the concept is that you maintain from either end. The Thames Water main is sleeved, so if there's any failures in any of the sections, it can be pulled out and repaired and pushed back in again, rather than having to dig up the highway. So there you see some of the ops using a low headroom Keller piling rig below the running lines. That was all completed through 3-day shifts, and we are back up to highway level now. So the only residual utilities that we need to divert is the Thames Water connection points and the sewer that is imminently going to be starting. We've sunk the shaft. We're ready to start bringing that through. Just use that photo there just to describe some of this, again, some of the Thames Water challenges. So we're coming through, and you can see here we've got these precast elements providing retention to the public realm and cycle route there. On the other side of the highway, it's a similar arrangement. The angle, so obviously you can only tunnel in a straight line. The angle that comes out from the car park and to about to clear the foundations of the Westgate Hotel that sits outside the highway, is such that the termination point of the sewer has to be integrated into these precast concrete units. So we're building a bespoke connection chamber for the sewer out of these elements, and then lifting that into place to receive the sewer. That's one of the reasons the sewers hasn't quite been thrust yet. So we need the exit port to be able to connect that in. Then everything goes up Botley Road, and then the connections were as challenging sometimes as and they still are as the actual route that the utilities took underneath the railway. With all the utilities, we can go further north because we've got existing signalling gantry and running underneath our assets, so we didn't want that. And then to the south again, we would have to buy a hotel and various other residences to be able to achieve the alignment to go further south. So the only route we could take was through Botley Road. So yeah, that has taken, one of my key takeaways from this project is really realise when and get the utilities in early, particularly if you're doing a project like this. A lot of rail engineers work on essentially long lines of route where you might have the odd utility to move, but don't necessarily realise the complexities and interdependencies with utilities, particularly when they all come together. And particularly Thames water assets, because they are large, heavy civils assets, unlike fibres and electrical wires that can be pulled quite easily, and don't like being turned off. And it's hard to provide, a diverse route relative to power or comms. So how I practically do that is ECIs, I would say, and look at getting these ECIs to a much more developed level of detail at AIP stage, rather than right into detailed design where almost sort of preempted doing more surveys and more engagement with the utilities companies at that point.
Oh, sorry, what's ECI?
Early contractor involvement. So I think it's a term that might fall out actually, because it's kind of just best practice. You speak to the experts in good time, I think, rather than making assumptions. And I think that was very
you
clear.
without them committing you first.
Yeah.
So, another question. That's right.
I was going to say there was one question I've just noted.
That's a really good question from Simon online. So the question is, did the incident at Newnham Viaduct affect the programme? Well, I was gutted we couldn't sort of capitalise on it really, because we're still flapping around with utilities and not really doing anything with the railway. Yeah, if we were a year ahead, we would have had more notice about it. We would have jumped on it and it implemented a lot of the infrastructure changes. However, we had, right, when did Newnham occur exactly? I think it was early 23. So I think we were gearing up for the blockade that I've described. We obviously weren't ready to deliver that yet. And then we did actually think about delivering. We had to south of Oxford, there's a footbridge that runs over the car park, so about 200 metres south of Botley Road Bridge. We were building the foundations for that. Didn't really affect us much in that respect. Just made the station a bit quieter. Rail replacement buses were a bit of a conflict, but again, we had the space in the car park to be able to enable that. So simply didn't really affect it. I'll just say we could make use of that. 4-month closure of the railway south of the station. Yeah.
Just a quick question about not the railway architecture. Noticed some neat and pointy sort of designs, a pattern, and it was shown, I think, on the balustrades of the bridges. Yes, that one. Yes. Do you know anything about the architectural input to it?
Yeah.
Was there a lot of angst and careful design, or did it just happen? Or how was it done?
Yeah, so that's a really well planned question. So it's a nice segue into the next section, really. There have been quite a few iterations of the west entrance. The main Grit 4 designer, Sistra, designed a scheme which is 2 or 3 stories high with train operating company residents above it. We also had a scheme with the developer, an oversight agreement scheme whereby they would basically pay to build the whole thing with the benefit of gaining that land and the ability to operate the station above it. So kind of net a bit of a win-win on that. The staging of that didn't work, and I probably shouldn't go into too many more details about the scheme, but it was 7 stories high, looked really impressive, really very different to what we've got here. As COVID hit, as we were refining this, we also had a design advice panel meeting with lots of, it's an independent assessment, but with a selection of architects and very senior architects in the rail industry and outside the rail industry, with councillors, planners, and they said our design was an aspirational enough, but we're also looking to deliver to complement the Brookgate scheme, which was crazy big and was still about to go, would have need to go from full planning. With network grandfather rights, we just have to undertake prior approval of this scheme. So score against some elements, but not the full application. We wanted to have an MVP option that was really good value for money and the lower end of the budget range, so sort of £5 to £10 million mark for the western entrance. So we went out, we had a Grit 4 design for the station, but we went out to the market and contracted Idom, who are a Portuguese firm, I think, architectural firm. And they did a design sprint on the architectural design of the station and sort of tore the old one up and came up with this detail. So they spent a few days in Oxford. They were, well, what is Oxford about? What do people coming into the city from the west want to see? And one of the main conclusions was that Oxford's a city of walls and doors. A lot of which you can get behind unless you're a student at the university. But also be welcoming as a station, because it needs to be. So you're picking up the occupiers relief in the precast concrete. So initially we had it to precast concrete, it's now going to be cladding for quality reasons. There'll be some architectural lighting highlighting that. And one of the more innovative elements that I hope stays in the design on the bridge itself are these, because this is the entrance into Oxford. This is a brand, we've only got one road from the west, one road. So we wanted to make a feature of the bridge itself, an arrival, for everyone who's coming under the bridge or using the station, of these bronzy gold metal panels perforated to catch the light, not in the way that hits the driver's eyes, but just kind of glimmer nicely on the bridge itself. So I have warned the RAM about those route asset manager. I'm going to see him in a week, and I'm going to take some samples to him and see if we can get this signed off. So fingers crossed they remain in the scheme. So you can't actually see it, just about see it's not rendered on that side there. You've got a kind of clean, if you have a look on Idom's website, you'll see their architectural style is quite clean and a little bit brutalist, but also with the softening elements of the wildflower roof on top, which I'm going to focus on in a minute because it's quite unusual and there's some interesting features to it. And then the urban realm, this is slightly earlier phase. I don't have the visuals for the final urban realm, but it is I think it's even better actually. It's slightly different shape to it. There's more build up to the west with the levels, with more seating, and a more cohesive, slightly more cohesive design. We're also part of the overall design is to retain those 4 lime trees that provide significant screening up and down Crickley Road there to the house both ways. So the design incorporates those. We've also been asked by Oxford City and County Councils, being a cyclist, a protected characteristic in Oxford. A lot of people cycle around, and cycle parking station is super important. It's very much oversubscribed on the city side of the station. There's basically nothing on the western side. So we've built in further up the rise up Rochdale Way, a lot of cycle parking into the scheme as well. And then a cohesive urban realm, kind of providing this quad shape. So again, it's another hint to the colleges there, but a useful, but not too overly large, sort of more intimate urban realm experience, and an easy access route through to the station. Because again, it is secondary. So a lot of people use this as day-to-day travellers. They don't necessarily want to sit around a long time. They know the train they're going to get. They're going to go through. We do have one concession to a cafe or whatever the TOC or GBR wish to employ it as on that south side, with views out, glorious views out onto Brockley Road. To the north of the station, we have a waste handling area. That's really important for the future master plan, because a lot of the commercial and trainborne waste goes out to the city side. We've got a facility for Biffett lorry to be able to come in and pick up the waste and take it away from the north there, and then various storerooms to the north, M&E rooms to the north. And then BTP, combined BTP, TOC, small but hopefully quite useful multi-purpose rooms within the station and the gate line there. We also, Great Western didn't want this kind of wind tunnel through the subway, so we've implemented glazing all the way across the facade now. That's in there. That's what key design changes from that grid-free design you can see on the screen. But everything else more or less stayed the same. If you want to see the latest visuals, they should be on the NetRail website for Oxford Phase 2. So just Google that. Wanted that on the screen just to show that development actually from our grid 3. So the final section, I'm talking about green routes. So one of the challenges was, and we didn't actually have to comply with it, but a lot of new, all new developments, I'm being very broad brushing, so I don't know the law, but what we're aware of, biodiversity net gain 10% needs to be implemented on new developments, residential, commercial. So we were removing some habitats, so this went towards that net gain and enables us to achieve that. We've got a list of benefits here. Some are more obvious. So we've implemented a green roof. Clearly, biodiversity net gain is enabled. There's various different build types of green roof. You can literally plant what you want on a roof if you really want to, but some perform better than others. Sedum is a low maintenance but low visual impact plant you can plant on there. We've gone with a wildflower meadow because visually it is more impressive. There's a little bit more maintenance. It has to be cut at least once per year. Later on in the season, if it's been a dry year, you cut the dry growth off, and then you let the new grass come up in the later on in the summer. It was a bit of a hard sell to Great Western to go along with that, but the benefits, the cost offset are actually there, and I'll go into those in a minute in terms of cutting and maintaining that roof. It doesn't require any irrigation itself. Wildflower meadows are very drought tolerant. Obviously, they exist all over, and they will dry up and then come back to life with rainfall. Just running through these, then we've got some rainfall attenuation. So I'm just confirming with the designers actually that they have actually factored this in, because I don't want to pay all this for a green roof and then that, you know, we've got a rainfall attenuation tank that doesn't take this into account. So I check that is robust, but provides significant runoff reduction actually. So we're actually going up to 250 with a substrate, and the runoff percentage will be less than 40%. So significant storage, and then that's used by the plants to run the plants, but evaporative cooling. Now that in the summer reduces the cooling demand of the building. Again, I'm trying to get this quantified through various sources. Oxford Green Roofs, a company are working with us at the moment to refine this design, but lowers the cooling demand of the building. So you don't need to switch the aircon on because the roof is providing active cooling. I talked about the visual benefits, air filtration, so close to a very busy polluted road in Oxford, will provide some absorption of harmful gases and heavy metals. Other sites where they've removed plants and green roofs, the substrate contains these heavy metals, so clearly they're not going into people's lungs, they're going into the soil and then being processed. The build up is not that significant, so I'll go on to that in consideration. Sorry, I'll just go through the rest of the benefits. Urban heat island effects. So you've got this large thermal mass that's generally fairly wet, and the green of the grass itself reduces the surface temperatures by, you know, a fair number of tens of degrees Celsius, providing a kind of relative to the rest of the scheme that's quite concrete and there's acoustic walls and everything. It's a nice offset thermally in that area, particularly with residents sleeping locally. You know, if you quantify it, I don't think it would be massive, but it certainly is a benefit. Acoustic, so there's a fair amount of reflective surfaces. If we go back to the scene there, a fair amount of reflective, but there's a large amount of acoustic attenuation that the green provides, particularly when the grass is a bit higher and you've got that big thermal mass. So the mass of the substrate. And what I didn't realise until I got told about it, but it's obvious when you think about it, is that people are really, well, you know, our roof's going to destroy the roofing membrane and cause leaks. Wildflower, they don't root that deep and they're not that strong. They can't get through the roofing membrane. The only things you need to worry about when you're maintaining it is you go and cut it down with a strimmer, and you just check for self-seeded sycamores and trees. They're the ones that can do the damage. As long as you check for those, and you actually have a number of years to recognise you've got a tree there before it starts causing any issues. So you pick those up, pull them out, and you're okay. Putting the green roof over the top of the roof membrane mitigates the thermal expansion, contraction, and UV degradation of the sun on the roofing membrane. So it happily sits there without any degradation. So a well-maintained green roof will last the lifetime of the building, 120 years, without having to do any maintenance to the roof. That's the idea if it's maintained properly. But that's the sell to the asset manager and the TOC. So other considerations, I've talked about the cuts a year. So it's slightly harder in a rail operation environment. We're still looking at the details about how we use power streamers at height around an operational station. The various companies talked to, they don't want to work at night, so we have to stage that, have exclusion zones, or potentially close the western entrance for a day and get it cut. But that's still being discussed. Again, irrigation is required. Man-safe systems, quite simple in the design actually. So they sit with a large grid underneath the substrate, and you basically just use the self weight of the soil to support the man-safe. So you'd have to penetrate the waterproofing membrane on the roof. Under consideration, so we're ordering a fair 250 metres squared of wildflower matting is all going to arrive on site, and we're going to install it within 24 to 48 hours. it won't sit on your pallet. And you can't, well, you might better get away straight with water, but I wouldn't want to be the one who signs off on that. So it really needs to be just in time delivery of that element of the works. It needs to go straight to the roof and be laid. And then you have to water it over a period of 3 or 4 weeks, depends a little bit on the weather, but then it beds in quite nicely and then you can just walk away. If there's any elements that fail, you just replace those. If it's on matting, it's quite easy to do that. Fire safety. So our fire engineer signed off on this. He's happy with it. Essentially, just put fire breaks in, gravel around any skylights and any of the edging on the building. There's no concern about any OLE interface as well because of the vertical and horizontal separation between the two there. So there's essentially there is a slight risk that in very, very dry periods it could catch fire, but the idea is it would just smolder off and not go beyond any fire breaks. So yeah, that is a consideration that you can't really get away from, but the risks are very low and contained. You also, as I've mentioned there, to mitigate the risk of any spread, the growing medium can't contain more than 20 organic% content by volume with low peak, so it doesn't then sink down into the structure. Green roof specific waterproofing membrane, so all major suppliers supply that, generally slightly thicker to avoid root penetration from any trees that you haven't maintained. Self weight circa 200, the one we're looking at with the additional gravel for attenuations up to 300 kilograms per metre square, so it requires a fairly chunky structure below it to support it. It's not something you want to stick in your shed at home. But with the form of station and the form that we've got, it hasn't been difficult to support that weight. And there's also acoustic benefits for everyone within it as well, with that weight on the roof. So covered a few areas there, not everything on the project, there's obviously an awful lot going on, but kind of a few of the key and interesting, hopefully, points around the project. We're looking forward to delivering get the utilities out of the way, actually build the bridge, and then implement the station. The station itself is on platform, is fairly straightforward. I haven't covered that in much detail, but there's a waiting room, a cafe, and then top building is kind of replicating what we've got there today on platform 4 within the island platform. Obviously full PRM and infrastructure, TSI and TSN compliance, platform widths up to 3 meters to support the ramps of the trains, and fully compliant XYs on the copers to better bring it to service. Yeah.
So escalators and lifts from the 4 levels to the platform.
Steps and lifts.
Okay. And on the architectural scale drawing of the forecourt, there was a long building, and there was a piece in the middle, the top, that darker. What's that? Is that a housing or something?
Yeah. So that's the existing footbridge there.
Oh yes. Okay.
Yeah, so that remains as is. So that's the only element. So when you step onto new platform 4-5, or new apart from that. So we don't have a remit to replace that at the moment, and even the OLE due to go under that. The idea behind that is when with the subway, we're creating a stop connection for a future connection underneath all of the platforms. That probably stay in, but when its life expired, it could come out. That's the idea behind that. Canopy covering 80% of the platform. So fair coverage there. Obviously, really important, opposite to pull people on the platform in periods of poor weather to maintain ped flow. If you know Oxford, you know the importance of this scheme. The amount of people, particularly on London, obviously always on London bound. Trains arriving from London, is the ped flow coming out the station is poor. There's generally quite a high wait time. So the immediate benefits of the scheme once we open the western entrance will be realised very quickly in that regard, and go on supporting the future development of the station.
And what's that raised section roof halfway along the canopy?
So that's the existing station building there,
Oh.
just behind it. So you're just seeing it behind, and that's the central atrium for the station. The actual,
That's already there.
yeah, the actual,
And that's the downing platform, so we're not seeing the up.
yeah. So this is the up platform here. It's behind this retaining wall acoustic barrier. So this train is on platform 4. This train's on platform 5. So then you've got the canopy, waiting room. What's not shown there is actually there's the lift shaft. So it is there. The header into the lift shaft is there. You're looking beyond it, then to the platform 4.
So it's raised bit is.
So this bit here.
Yes.
So if you think this is a fairly simple steel framed building,
What is it?
in the centre there's a section glazing here, and it's just a larger atrium. So the roof height just increases to make it more area in, and that's above the existing gate lines to the city side of the station. So that's all existing.
Does it need any access to the green roof? There's no edge protection.
Yeah, absolutely. So as I talked about, man safe is your edge protection. The access is from the waste handling yard. There we've got a series of steps, so that it's a permanent staircase running up there. We didn't want people handling hand tools and strimmers going up a narrow caged ladder. We also need to think about how we get the green waste off the roof. So I mean, if I kind of ton bags, and we're looking at sort of a small crane to be able to take that down off the roof. Yeah, so there's good stepped access, and then the ops will connect onto the man safe. That's something that they are used to doing. We don't like, or the designers don't like, or greeneries don't like employing traditional edge protection around the outside, because it kind of takes away the visual effects. So the operatives are used to working on a man safe. Yeah, just as long as they don't over specify their cutting blades. Yeah, the strimmers work well. I keep pushing for a scythe cupboard somewhere.
Are you looking for time? Because
Yeah, I'll probably take a couple more questions.
there's one on there as well, and there's two
We've
here.
got 2 go. We can do a still all 3, but
Okay.
I'll keep them fairly compact. Let's do one online.
Levels.
Simon, provision for level boarding on newly constructed platforms. No, we're just installing standard platform heights in line with net rail standards. So 905/745 offsets. Yeah, that's that.
Yeah, about 15 years ago, we had a very big scheme to have a bay platform in the car park south of the station.
Yes.
10 carriages long, so the London-bound trains could wait there and lay over and then go directly out. And there was
So that's on the city side.
on the upside, that's on the east side, south of the
Yes.
station, with a massive transfer deck,
Yes.
fully designed.
Mhm.
Like we've got planning approval, detailed design, got everything, and then just went in the bin. I presume that stays in the bin, doesn't it?
That is standard.
Right, okay.
I need to. When was that completed?
About 15 years ago,
15
I
years
worked on the whole design.
Yeah, I need to sort of dig that up. 'Cause,
Yeah.
you know, delivering what I'm delivering now,
Yeah.
it'd be really interesting to have a look
Well, it
at.
was literally impossible because of the problems of the Botany Road. We didn't touch the Botany Road at all because it was impossible with the big water main and everything. And the level crossing that was mentioned, that stayed in place as well. So you had this massive bay platform coming up through the car park and stopping there.
Mm.
And then you had to have a transfer deck
Mhm.
with 2 sides to it, public footpath side,
Mhm.
and the other side where people have paid their fares, so they get between the 2 parts of the station without going out and coming back in again.
That's I found a little bit like the old LMR terminus at Morley Road.
Yeah.
When was that ripped out in the
Yeah.
40s or 50s or whatever? To the north of the station. So that's an interesting historical thing to look into if you're interested. Obviously, actually, when we were starting the project, they were working on the deck that goes over the sheetwash cut.
Oh,
So
right,
the just called swing bridge. That's one. Very very noisy grip blasting, but it looks really impressive today. They've restored that.
so the other time, let's just see, it's a quick fix, just to get one extra platform in the
Yes.
station. With minimal cost, didn't move anything else to it.
Yeah. Well, you never know the road we're going. That might be willing to take
Yeah.
that from the car.
Okay,
You mentioned the subway. Is this an extent of the original subway or?
No, the original subway is now full of grout. So there was run between platforms. We use that for cable routing as part of early schemes. Not generally not big enough. The new one is between 4 and 6 meters wide. On a new site further south of Lyman to then tie into the new staircase.
Footbridge, you said that over a name.
The bridge to provide that kind of airflow diversity.
Maybe the blot on the landscape.
The last question from Albert.
Okay, can we just go back to the track over Bottley Road?
Sure.
You said there's restricted ballast depth. Are you using full depth concrete sleepers?
Yes. Yes.
I did wonder why particularly. We could go to shallow ones. What sort of spacing have you put the sleepers at? Are they normal standard spacing?
Yes.
Okay. And
Let me just check on the shallow depth. Actually, I don't think we are, but it's been a while since we looked at the track design because we've not done anything with it for a little while. So I could come back to you on that if you want.
okay, it's just interesting why you'd use full depth. Why not use shallow depth?
Well, it makes sense. It makes sense. It's obviously a trade-off between, that track resilience, isn't it, and getting the ballast depth.
Yeah, the ballast depth is more important than, yeah. Okay, and one other thing about that, then, you will want to keep impact down as much as possible from any type of traffic that's going over there.
Yeah.
Has been a definite policy to have only flashbook wells over the bridge? Are there any thermic wells at all?
I assume flash building.
All flashbook? Yeah, okay, that's fine. Okay, thank you.
Brilliant.
Okay, well, we're 15 minutes beyond your target time. I've been watching the clock. We'll call it quits there. I'm sure this could go on for another half an hour. So thank you very much. Mark, could you do a vote of thanks, please?
Brilliant. Thank you, Lauren. That was a fascinating thing for me. It was eye-opening just to kind of take your first statement, because this is 50% a rail project. Actually, you quite ably show that it's utilities, services, non-railway engineering. I guess that most of us are used to that. So
And stakeholders too, with that.
yeah,
With that side.
quite undertaking as well. And I think probably with just I'd like to say that leads me to the next bit, which is hopefully we can get a visit at some point to some of the non-operational bits. But thank you, and we appreciate you coming down, and we can show our appreciation in the usual manner. So that would be great.
So Keith, thank you very much. Lovely to meet you all, and sorry we've kept you long. No, we should have. But super speaking.
You find your way out all right?